Good morning.
Good morning.
So first thing I wanted to go over, show you, I should say, is just a little trick in Excel to help with solving equations kind of quickly. I mean, there's ways to do it within MATLAB, Python, different things too, but it requires a little bit more code. But within Excel, I don't know if you guys know about it or have used it before, but there's this tool called Solver. So it's under the data tab. It comes with Excel, but you have to install it. Like, it's not automatically there in this analyze. There's also a statistics package that you can put in too. That's not too bad either. I don't know, just remember the steps. I think it's like under options. You have to install it. You can always look it up, but add-ins. Where is it? Yeah, Solver add-in, and you just go to the add-ins, and these are different. So the analysis tool pack has some stuff with statistics that are neat too sometimes, but the solver, you have to add it. Okay, and then it appears. You don't have to go and download anything or anything. It's just not there unless you do this. What's neat about it is, here's an example from the text, from the back of the chapter, 1620, and I have this file up on Canvas, and I have updated it to, to the proper example number. So at the end of the chapter, it's 1620, and then there's another one, 1644, that I updated it to. And so within this one, what I did here, let's change this number to something different, is set up the problem so it was a carbon and oxygen to CO2, and that means in the reaction balance, X was carbon, was the leftover carbon, Y was O2, and Z was CO2. Okay, so, and that's the moles that goes with them. And I have basically just a guess here on X, Y, and Z just come from the carbon balance. Okay, so maybe I should put like comments. So this is from oxygen balance, and this one's apparently, anyways, I can do that later. And this one's from the carbon balance. Okay. So what I did was just set up the oxygen balance as a function. So you do the oxygen balance and just solve it for Y. So then that means it's just a function of, in this case, Z. And then Z solved it, and Z ends up being just a function of X. So X we need to solve for, and I just put in 0.6, right? If we put 0 in, it changes things. I want some values in each of them, so I'm just putting a guess of 0.6, okay? All this stuff is just chapter 13 information. So I calculated the mole fraction for each of them. I have the mass, or the molar mass. I have mass from using the molar mass and the moles, and then I have mass fraction. Okay, and then concentration, which is something used by instrumentation. So it just kind of, the top is just the information, and these are just kind of calculating it off of the moles. Okay, I have then N total, the total moles. Okay, this is pressure. Okay, and then for this problem, it told us, I forgot what temperature. I have to look at it, but let me see. It was at 3,800 Kelvin. So going from the table A28, got the natural log of Kp, which is this, and then solving for actual Kp is this. So at that temperature for this reaction, it is that KP, right? Well, now, so it's now that's the actual one. We can look at what would be when we set up our equation with the moles for our equilibrium constant with all the, the moles raised to the power of the stoichiometric coefficient, and then on the denominator and then the pressure with the total number of moles. So it's all there of setting it up of what the equilibrium constant is from that side of the equation. So then this needs to equal this, okay? So the Kp calculated from the table, that constant, has to equal what you calculate based upon the moles, right? So here is the air. Okay, I just do an absolute value of the difference between those, and we need that to be 0, right? Well, we could set it up in the algebra and get our answer, or do this solver. Okay, so the solver comes up with this, and you can set your objective cell. So in this case, I have D21. So that is the objective cell, and I want to minimize it because I want that to be 0, because I want this side of the equation to equal this side of the equation, and this is the difference between it. So it's minimizing it, and it's just going to change this cell. So it's only changing x because everything else is calculated off of that x value. So if I just solve, so this method is a nonlinear solver. There's a simple one, which is more linear, and then there's actually a neat evolutionary one, so more of kind of what you did within ModComp with the parents and children and all that. It does all that kind of stuff within Excel, so you can get all your different variables within it and see what it does. Okay. But let's do the nonlinear one. You just click solve, and it iterates. It's basically trying a whole bunch of stuff, and sometimes it doesn't converge to the right. If it converges and tries to go the wrong way in the solution, you'll get an error. It'll say it didn't get a good value, so you can restore the original one. But we can see this is basically 0. It's within the tolerance within that the settings, the options. So here's the precision, so how far it's trying to converge to, right? So if then when we solved it, iterates, keeps trying a bunch of different x's until that is 0, okay? And there's the answer. So that's a simple solver method where it iterates a bunch of stuff. There's also, if you do it with 2. So here's an example, 1644. So it's similar to your homework where you got to set up you have 2 now. You have an overall equation that, in this case, water is going to all these, there'll be leftover water, but then hydrogen, oxygen, and OH. So you have 4 things that you're going to end up with. So you have X, Y, Z, and W. So in this case, I calculated you do hydrogen balance and oxygen balance. So in this one was from hydrogen balance. And this one's from the oxygen balance. Okay, so they're based upon it and just as a function of the other variables. Okay, so right now I have 0, but if I had just say 0.6 here, say 0.2 here, right? So now these are calculated based upon what's in X and W. Okay, X and W are what we're going to iterate and just try a bunch of values until it works. Okay, so here's from the oxygen balance set up as a function of X and W also. Okay, and summed, and then all the same stuff you see here just calculated off of what you have here. Pressure was 1 atmosphere in this problem, and then you have your 2 equilibrium equations. So we have water going to this, and we have water going to these 2. So it's setting up those, we get the temperatures 3,400 Kelvin. So we go and get our Kp values, okay, from the table, and then we set up our equilibrium constant equations that are based upon the moles right here, pressure and total, and again here pressure and total. So there's an error. This needs to be equal to this, right? Because that would be, subtract the 2, it should be 0. The second one those 2 need to be equal, right? So those both have errors. So basically I did a root mean squared calculation for it, or you could have just did absolute of each, summed them or something like that. That'll work too, but this is my error that needs to be 0, right? So then if I do the solver again, so I already have it kind of set up a little bit to help, but I have the objective cell as this one, okay? You want to minimize that objective cell. You're changing these 2 variables. So now it's going to try to change 2 variables to get the answer, okay? So 0.6 and 0.2, and I put some constraints on it so that it doesn't find a solution where the moles are negative. That's what this is. Especially because there's, this raised to the E over here in our equation causes some issues if, you have certain values. When you, right here, inside here, you can get some weird values from it. All right, so let's solve it. And that ends up getting an error of 0, okay, and you have moles. And in this problem, I think they were asking for, oh no, it was the last one. The last one asked for the mole fraction, but that's why I had the mole fractions calculated. All right, so you have error of 0. Sometimes if you have the wrong starting points, it might converge and not give you a good answer. So you might have to mess with your initial guesses on these, okay? But it's a nice, simple way, quick way to do a solver method to solve some equations with iteration, some nonlinear equations if you have to solve them. I use it every once in a while depending on what I have. So I use it for other things too, like if you're trying to achieve something, because this solver this is min. So this one we're just trying to make it, it's just equation 0. But you could use it to find a maximum or a value of. Maybe you're trying to find an optimization problem or to maximize something, or you need to change a bunch of variables to get a certain value that you want. Then you can do a value of. So it's a useful tool for certain engineering problems to get a quick answer. More powerful, there's stuff in MATLAB and different Python and different programming languages, but it takes a little bit more time to get those set up usually. So this one's a nice quick one when it's not so difficult of a problem to solve. Any questions on that?
If, I guess, bringing this back to the class context, on a test, if we were to solve a system of equations like this, would we need to use like Excel or MATLAB or something?
No, I will strategically pick the problem that it doesn't require you to do that.
Okay.
Or I would say if it's, to solve for one of them, it might just be an iteration with a single variable or something like that, where you just do an initial guess or something, and it'll probably take two steps through your calculator or whatever. Through like this one, you could easily, possibly done it within the calculator with an initial guess and solving the new one. That would be the most I would do. But even then, I would only just look mostly for you guys to set up the problem correctly. And then whether you got the right answer or not, I'm not as concerned. It's more that setup problem. Like that's more than the calculator side of it, which I'm less concerned about on a test. I'm more concerned about the process.
Okay, that makes sense.
Yeah.
I like this Excel option. That's neat. Yesterday I did a YouTube crash course of MATLAB.
Oh, to do it, yeah. This is yeah, and it's there, and it's very, very more powerful than this, but it requires a lot more effort to get there for especially for a simpler problem like these.
Cool, neat. Thank you.